Okay, so this is the first part, well, first repeat of the previous class today, for sections 2, 4, and 6. Mm, and we're talking about the hand tools. And right off the bat here, this is a very funny picture because, well, there are two guys, and one of the guys is crushing his thumb on the, um, wow, these would be the cavemen a long time ago, and they would use primitive tools to crush their thumb. And right now, these guys are using a little bit more modern tools, but still crushing their thumb. So accidents happen. So yeah, it's a very funny, yeah, hilarious, very funny picture. Okay, cool. All right, we got the funny part out of it. Right, now let's look at some of the tools, some of the most common tools that you might be in contact with while performing jobs that have to do with things that we're teaching you in this course. Right, so these are wire cutting pliers. The purpose of that is to cut wire. Right? We can what can you say about what can we say about this particular tool? Here's the anatomy of this wire cutters or wire cutting pliers. Sometimes they are known as side cutters. Right? Well, we have plastic covered handles. We have the jaws, which are ended with the blades, and the blades are doing the cutting. And in order to make the jaws move, we have that joint here that the jaws are pivoting around that joint. Right, pretty simple thing. And these will be the grips right here, that are part of the handles. Right? The grips right here. Okay. Nice, should be nice and comfortable for us to cut wires. Are we going to drive nails into the wooden boards with that? No. Can you screw the screw? Can you tighten up the screw? That's going to, no, it's used. This tool is used to cut wires. And I'm going somewhere with this. Now, here are the wire cutting pliers, and here are the snips. Both are used for cutting, although they're supposed to be cutting different things. And let's look at the anatomy of the SNIPS. Well, they do have grips, they have handles, they have, well, these guys have locking latch. So when you want to store that and prevent that from them opening themselves by themselves, then you would just kind of hook this on to this locking latch. And linkage screws, that would be the part of the locking latch as well. And of course, yes, you do have the pivoting bolt, or same equivalent as the joint for the other ones. And of course, you have the blades, but they're shaped a little bit in a different way, because these are meant to cut sheet metal. These are meant to cut wires, and these are meant to cut sheet metal, and they should be used as intended. Right? Adjustable wrench, adjustable wrench. So, what do we have in adjustable wrench? We have the handle. Of course, yes, we do have the handle. We have two jaws. One jaw is fixed. See, it's part of the whole assembly, and that jaw is not moving. And you have the adjustable jaw that by turning this worm screw with your thumb, you can move this adjustable jaw closer to the fixed jaw and further apart from the fixed jaw. Um, mm, and and then you can adjust the size of the wrench. And says, do we have to know the components of each tool? I'm not going to ask you to remember these. I might ask you for some on the test. I might ask you some questions about some of the parts of those tools. However, it's going to be an open book test. So you're welcome to look at these notes, and you can find. So that's how you retain the knowledge and the information that we're giving you on the when it happens to you working on site using these. Nobody's going to examine you from on the parts of the tools. However, we're just going over them. So we could carry on the lesson. So when we're referring to some of the parts, we have something to refer to and name them properly, so we could carry on the lesson properly. The stuff that I'm trying to get through is the type of the way you use that. So that's kind of more important, and it would be nice for you to to remember how to use it as opposed to how to not use it. So no, you don't have to memorize all those parts. Although as you go along and use those that terminology is going to stay with you whether you want it or not. It's just that's how our brains work. So let's take a look at how to use them. This particular tool. Well, if you can see, here's the fixed jaw right here, and here's the adjustable jaw right here. And same thing on the other picture. You can identify those parts. Here's the fixed jaw, and here is the adjustable jaw. Now we're turning those wrenches both the same way. We're tightening up the bolt on using this on whatever it is, using this tool. All right, so look what happens when we tighten the bolt, positioning the same tool one way and the other. If you position the tool this way, most of the pressure is going to manifest itself on the fixed jaw. That's where the work is going to do. That's where the most pressure is going to happen. This adjustable jaw, well, it's mostly its job is going to be limited to glorified guidance of the tool around around the shape of the bolt. So because the fixed jaw is fixed and it's part of the bigger assembly, it can handle more work. If you flip that same tool and you turn it the same way, see with the arrow, the way it is, then if you flip it around, then this fixed jaw is going to do most of the work. That's where the pressure is going to be, the mechanical pressure. Now, what can happen here? Well, this is, well, not as fixed as the other one, this jaw. So what can happen? This can break if the tool is just about to, to be finished with its usage, or things can get a little bit out of alignment and you can slip. The whole thing can slip. And what happens when you apply a lot of pressure on like a leverage pressure on the handle, and you're going to keep pressing on that. And if something lets go all of the sudden, then your hand is going to go towards that motion that you're pressing very quickly. It's going to travel very fast, and you can injure some of your muscles, or tendons, or you can hit something with your hand and you can get like a mechanical injury happening to your hand. And since this is, let's assume that this is going to be your main income, um, that you're going to support yourself and your family with that, then any injury is not welcome, because that could be time off your work. All right, so this is how you use this type of adjustable wrench. Take a look at this, and maybe you can play this part a couple times until it actually becomes clear. And if you're still not clear on this, talk to us during the labs. Then we can demonstrate the whole thing live. Well, not the injuries, but we can give you a little bit more explanation as far as this. Okay. Now, let's take a look at the hammer. Hammer seems to be one of the most primitive tools, primitive in a good way. Um, it's one of the most basic tools that you're going to use. However, you still need to know how to use this basic tool so you don't get injured and you do the job that you're supposed to do correctly. Right? Well, let's look at the anatomy of the hammer. Here's the grip and here's the handle. Well, that's how you grip the handle, by holding the grip part of the handle. And here's the eye. That's where the handle meets the head. Okay, so this part here, that is the head of the hammer. And right here, when these two meet, that's the eye of it. All right. Then this head has a face and a claw or a pin. In this case, would be a claw. And well, there's a throat of this thing, so that's where the head is just becomes joins with the face. Well, this is the part that we use to hit the nails with, and this is the part that we use to remove the nails from the, let's say, wooden board. Uh, and here is the cheek, which would be the side of the hammer head. Now, we should never use the cheek to strike nails or to do the work. It's just a part of the assembly. That's not the part we use to hit things with. This here is the part that we're supposed to, the face is the one that we're supposed to hit the nails with. Now, that's another example of what the claw hammer looks like. Here's the face that you hit things with, and here's the claw that you are going to remove the nails. It's used to remove the nails from the boards. All right, now here's another example of a hammer, and instead of the claw, it basically looks almost the same as the claw hammer, but it's called a ball peen hammer, and it has the ball peen on the other side, as opposed to the claw here with the claw hammer. Now, there. The difference between these two is, first of all, its intended use. This hammer is designed so it can handle hitting metal objects with. Of course, the nail is a metal object as well, but it's not that type of a metal object. This would be hitting a bigger metal object, such as a chisel. Right? You could have wood chisel, which is made not out of wood, it's still made out of metal. It's just meant to be to work on wood. Or you could use something that's called a cold chisel, just like the temperature, cold. And what does that mean? A cold chisel is that the chisel is supposed to be used in regular, normal, cold temperature, not cold, but regular temperature, as far as that metal that you're working on is not supposed to be heated up in order to be worked on. So that's the terminology why it's called cold chisel. Right, as opposed to having the piece of metal or whatever you work the material heated up in the forge, maybe in the oven, and then having to shape that while the metal is hot. I'm pretty sure you've seen some of that show that's called, what's it, Forged in Fire. So that would be that type of, not cold, things are being worked on while they're hot. So cold chisel is meant to be used on the metal that it's not heated up. All right. Now, you should never, ever use the claw hammer, which is meant to drive nails into the board. Okay, here's the snips are used to cut sheet metal. Yeah, thank you. And well, can you cut the wires with the snips? Well, you're going to make some sort of a cut because you got the jaws and you got the claws and you have the blades on the claws, but you're not going to do a good job. The wire might get damaged or something like that. Well, you should use the things that are intended for the usage. Okay. So, and we'll talk about it a little bit later. Right now, we should never use this claw hammer to strike a chisel, for example, which is a metal object. No metal on metal striking on that. And the reason for that is it's not the shape. It's the shape, but the way this head is made. the metal, the type of isotope the, that the metal is used, the steel, the isotope of steel with carbon and whatnot, and the way it is manufactured as far as heat treatment and whatnot and hardening, it is not meant to be hit to hit metal when it's ready to be used. What can happen when you hit metal on with this type of hammer? You are running into a risk of this part breaking, because the way this isotope, this metal part is designed structurally, is not supposed to handle that that impact on metal. And when you use that to strike metal objects, then this can break. And when it breaks on impact, it can chip, and those chips can fly out at a high speed, and they can actually hit you in the eye. And that would not be a very happy situation, because, well, aside from paperwork, then again, it will be at your time of work. And if this is the type of work that you do to support yourself and your family, then needless to say that it's not going to be a happy situation. And I don't have to explain, probably, right? It's self-explanatory. Now, if you want to strike metal objects, you use the um, ball peen hammer. This isotope, this steel, the structure of this steel is designed so it can be used to hit metal objects. Of course, you have to also know the metal object that you're hitting to see if that is not going to chip on you, right? So things that are supposed to be strike, which would be tools that are meant for striking, to be hit, to handle some sort of impact. And chisel is one of the most common things. We'll be looking at those during the second part of this lesson, which is probably, yeah, it is Friday, not probably, it's going to be Friday. Okay, so the other thing is, like, for example, if you are removing the rotors, if you're doing your own brake job on your car, you want to replace your own brakes, and you want to replace the pads and the rotor, then, well, when you take the tire off, then there's that rotor that basically sits there. It's not fastened by anything. It just sits there by the pressure of the tire that is fastened to the whole wheel assembly. Then, in order to loosen that up, the rotor, you might have to hit it with a hammer. The best thing would be to use a little piece of wood, so you could hit the wood, and then which put against the rotor, and then you hit it with a hammer. But if you need to just hit the rotor, which is metal, you would use this type of hammer, never this type of hammer. And we know why: because the way the steel is made, the manufacture of the steel, and the treatment and whatever goes that has to do with the procedure of producing this type of metal. This is not designed to hit for a metal on metal impact. All right. Now let's go a little kind of a short confirmatory type of a quiz. Now, this is not the PowerPoint, so the answers you can see right away. Well, let's just analyze some of the questions and some of the answers that have to do with this thing here. Question number one: plastic covered handles on wire cutting pliers, which is the side cutters or the wire cutters. So we're talking about the plastic covered handles, right here. All right. They're handled, they're made of metal, and they're covered with plastic or rubbery, some sort of elastic kind of a material. So when we're talking about that, plastic cover handles on the wire cutting pliers might be used to cut low voltage live electrical wire. What's a low voltage? Well, low voltage is the one that actually you have in your outlets in your power outlets at your house, which would be 110 volts. That is considered a low voltage. Some people refer, when they talk about low voltage, they talk about like data signal, and no, that's an extra low voltage. The low voltage is the 110 volts that you're using in your house. That's so. Are the plastic covers meant are done in a way that they're designed to protect you from handling the low voltage live electrical wires? True or false? No, the plastic cover handles are for comfort and ergonomics only. Um, Always cut off the electrical power, which means always de-energize whatever you're working on. You should never work on live circuits, because you're running into a risk of um, well, electric shock, or what could be worse, electrocution. The difference between these two, electric shock is basically you get shocked by the electricity, and electrocution is, well, you're dead. So, all right. Uh, Now I'm going to stop a little bit to talk about ergonomics. We'll talk about this ergonomic thing a little bit further in the next during the next class. But let me give you the heads up. Ergonomics. What's ergonomics? Ergonomics is the study, part of the science that talks about or studies the uh, well, what type of insulated tools do you need if you, okay, I'll just stop, look at the question. What type of insulated tools do you need if you have to work live? Um, I'm not going to talk to you about working on live, because the thing is going to say, always de-energize the circuit. But when you get close to a live circuit, there is certain protective equipment that you're supposed to use or wear, not to work on the live circuit, but maybe to turn it off or disconnect, or be even close to that live circuit. And we will talk about that once we cover the arc flash topic later on as we go along. But a good question. Thank you very much. That gave me the opportunity to explain that. Never work on a live circuit. We're not supposed to work on a live circuit. And part of it is safety. The other part is that live circuit, when you work on live circuit, you're altering the circuit while things are being live. So when you disconnect some part of the circuit, the other part of the circuit might not be able to handle the change that is made, and you can run into a risk of damaging the other parts of circuits. Plus, one of the most important things, it is dangerous. Should not do it. But we'll talk about when we talk about arc flash later on. Okay, question number 2. When tightening a nut with adjustable wrench, always pull the wrench toward you, never push the wrench away from you. And it is true. And this is part of it we're talking about. This has something to do with, where's the adjustable wrench? There you go. Part of it is putting the proper pressure on putting the pressure on the parts that actually can handle this pressure. Okay, there's a less of a chance of something happening if you are applying the mechanical pressure on the parts that are more rigid. Right? This is less rigid. This here, the fixed jaw is one piece. This is mechanically constructed and moves, basically, it's a movable part. So when you have a chance, please position the wrench so the fixed jaw takes the hit, or does the most of the work. Plus, also when you're pulling towards, what does it say here? Pulling gives better leverage, so you get, well, the way we are constructed as humans, it gives us a little bit more leverage when you're pulling. But sometimes, um, you're going to have no choice because of the positioning of the equipment and the arrangement of the parts and the positioning of yourself. Sometimes you're going to have to do a little pushing, but always keep that in mind, and you're going to have to be extra careful when you're pushing. So that means that try to pull because it gives you better leverage and more comfort. And if you get better leverage and more comfort, then less of a chance of an injury. Okay. And balance gives you better balance as well. But most importantly, the force of the pulling should be on the fixed jaw. And this is what we just talked about. Okay. Let's do another thing. Claw hammers might be used to strike wood chisels. True or false? No. Claw hammers are for driving and removing nails only. That's it. Right? And we pretty much covered that in the last few minutes. Mhm. Question 4. What do we have here? Screwdrivers might be used for purpose other than driving or removing screws, such as prying open can lids. True or false? Well, there's the first of the two stories I have. There you go. Bach has a story again. um, as I said in the previous class, there was some time ago, and you were going to participate in some of those sessions as well as you go along with your working career. It was a first aid training, and some of those are being run by nurses, qualified nurses to do the training, and some other medical personnel. And most of the time, pretty much always, those people are experienced with time on the job. So one of the nurses told us a little tiny story, which I'm going to repeat to you. She used to work in emergency department of a hospital, urgent care. So that's where 24/7 people get injured, they show up. And that hospital was somewhere out a little bit further than we are here, kind of Ontario's beautiful north. And that was during the camping season, summer season. People go out camping and whatnot. Excuse me. And she said that most of the injuries, statistically, far, most of the injuries by far would be people coming to the emergency department of the hospital with their hands slashed because they were opening cans with things other than can openers, and they would be improvising, and that's how they would get injured. And it was just, well, in a weird way, funny story, because everybody had a smile. Yeah, okay, everybody had done some of that, and hopefully we didn't get injured. It is, but really, it is not funny because people get injured that way. But just keep that in mind. That brings me to that point that I talked to you about a couple minutes ago. Is basically the tools that the you should use the tools that are intended for the job that you do. Now, statistically, um, statistically, if you do, whatever you have to do is not part of your job that you support yourself, that's not your main income. Like, for example, there's something that you need to fix on your kitchen drawer somewhere there. So you go to your kitchen junk drawer and you get just take a look at it. Oh, I don't have the proper tool for that, but I can improvise with this. So statistically, you have a less of a chance of injuring yourself if you do the same thing repeatedly during your work hours. If this is something that you do all the time because you do it more often, so yes, statistically, you're going to get have a more chance of getting injured than the previous example that I just gave you. Right, but what happens if you use the tool that, well, for the job that you use the tool that was not intended, was not designed to do the proper job? Well, you're going to improvise using that tool. And once you improvise, then you're going to handle that tool not in a way that the tool was designed to handle. And sooner or later, you're going to get into a risk of getting injured because you are not handling that and you're applying some pressure this way or that way, uh, and then you actually can get injured, and this is basically the immediate type of injury as opposed to prolonged use, due to prolonged usage or prolonged exposure. These are the different other types of injuries. We'll talk about those too later. Right. Also, what brings me to the next point is that if you have a tool that is designed to do the job that you're supposed to do, but let's say that tool is not in the proper condition. Like, for example, a knife that is supposed to be sharp, but it's not. So there's that old cliche saying or example is that you have a more chance, you're running into a more risk of getting injured with a dull knife than with a sharp knife. A sharp knife, you know it's sharp, and you're going to be naturally, you're going to have that extra carefulness when you are handling that tool. But when you put the blades to the surface that you're supposed to do the job, it is going to respond as intended. Now, if you have a knife that is not sharp as it's supposed to, and that's it's supposed to be, and if it's a dull knife, then then the improvisation begins, right? You're going to start improvising on how to use it. So, which means you're going to apply different pressures at different angles. You are going to you're going to hold the tool in a way that it's not meant to be held, and add all those factors into the equation, then that's when that's the risk. That's when the risk of you getting injured goes higher. So that's why that's that good old saying that you can get yourself hurt quicker with the dull knife than rather than a sharp knife. Don't get me wrong, sharp knife, you can get yourself injured with a sharp knife, and that's for sure. But that's the reasoning behind that. All right, now let's keep going with some of that analysis here. SNIPs are permissible for cutting wire, true or false? And we just talked about it. False. Wire cutters are correct. SNIPs are for cutting sheet metal, and the wire cutters are meant to cut wire. Proper use of ball peen hammer is striking chisels and punches. Well, yes, it's true. It's the ball peen hammer. This is the claw hammer. You don't use that to strike chisels and punches. The ball peen hammer is meant to strike chisels and punches because you have that metal on metal impact. And why is that? I'm going to repeat. It's the way the steel head is made. The structure of the steel that is the way it's manufactured is meant to be used for metal on metal impact. This here, you can't. You should not, because the steel is not designed in such way. And when you hit metal on metal impact, things can break. It can fracture the surface of the hammer, or the other thing can fracture, and chips can fly, and they can hit you in the eye. Chips can fly and can hit you in the eye. Well, I'm a poet now. So here, claw hammers are for driving and removing nails only. Okay. Another thing, screwdrivers may be used for purposes other than driving and removing screws, such as spraying out. So we already did that. Okay, wait a second. Here's the next page. There we go. A proper use of ball peen hammer is striking chisels and punches. Yes, it's a proper use of that. Okay. Also, you should never punch hammer on hammers. You know, sometimes people just get funny, and so, that should not be done. Okay, and things can fly and they can hit you, in the eye, right? Or the other eye, or both. All right. Question. Okay. There you go. So you see, ball peen hammers are specifically hardened. Okay, which is the structure of the steel. to strike chisels and punches. All right, let's go question 7 here. Safety goggles should be always worn whenever you are using hand tools. And I'm going to stop right here and talk about the goggles. This basically should be glasses or glasses slash goggles, but depending on what job you're doing and what environment you're working with. What is the difference between glasses and goggles? Glasses, all right, I'm wearing glasses. Are they airtight? Are they liquid tight? No. Things can get from the top to my eyes. The things can get from the bottom and from the sides. The safety glasses, they would have side shields, and sometimes those side shields can be attached to the regular glasses as sort of a safety measure. So that means if you, for example, if you're getting a tour of certain kind of a production plant or something and you're supposed to wear safety glasses, or sometimes they give you the option depending on what glasses you have that they will give you those side shields that you can clip on. So that still there will be safety glasses. Are they liquid tight safety glasses when that happens? No, things can just fly into from your eyes from the side. Will be like a dry object, but if you get your face splashed with something, yes, things can get through pretty much everywhere you want, everywhere you think of, into your eyes. So these would be glasses. Like goggles would be liquid tight, sometimes airtight. So that would be the goggles. There would be the rubbery things with the rubber band around it, around your head, at the back of your head. So, but sometimes people, when they talk regularly, they would exchange those terms. But I just want you to know the difference between those two. And sometimes you are required to use safety glasses, like in our classes. We use glasses in our classes. Man, I'm getting poetic this morning. And sometimes you're actually required to use safety goggles when you're doing certain type of work that involves harmful liquids. Right. So yes, true, safety goggles like glasses should be always worn when working with hand tools to prevent eye injury. Kind of makes sense. Now, you'd probably noticed that, well, in previous schools that you had and in our that you went to, and in our college as well, we are putting a great pressure on you wearing the safety glasses. And sometimes you might think, oh, it's not necessary because how can I get injured? Well, that's how accidents happen. You never know what can happen. It's the unpredictable things happen that cause accidents. And here's the second story that I have here. It's going to be quick as possible. I'm not going to bore you with stories. Here's Bach telling you stories. Here's a storyteller. But there's a reason why I'm going to tell you that. One of my first jobs, long time ago, was when I was working at a music store, repairing the electronic equipment. We'll be mixing boards, amplifiers, guitar amps, some of the electronics on the guitars, keyboards, and whatnot. I was the dude downstairs. I was the cool dude that people came with. I met a lot of nice people there. Right? Some of them cooler than mine. Imagine that. Me. All right. So well, so I was working on an audio jack that was part of a mixing board or an amplifier. I don't remember what it was, but I remember the moment. Right. So after college, yes, I was irritated sometimes when the professors told us to wear the safety glasses, wear the safety glasses, and some people got kicked out of the room for not doing so. We're trying to get you into a habit of wearing those safety glasses. So once you get to a habit, we're habitual beings. We humans are habitual beings. So once you get into a habit of doing something, then it doesn't become so hard. You're just doing it without thinking. So we're trying to get you into that. So there was a situation that I was desoldering an audio jack, and there was a piece of wire connected to one of the connectors on that. And I'm just saying to myself, I remember thinking that was 30 years ago or something, maybe more. Um, Nobody's telling me to wear safety glasses. There's nobody behind my back drilling me to work to wear the safety glasses. What can happen? I've done it 100 times. Freedom, yeah. So I put the heat to that thing, and the wire just spring loads upwards, and bang! I get piece of hot solder right into my eye. Not like, I was lucky that nothing happened because it was just, but that was the moment that I realized, well, I learned the hard way. Yeah, there's a reason why we should wear the PPE, which is the personal protective equipment. So based on that experience, I'm relaying that to you. So yes, it's the learning experience. Hopefully you won't get into a situation like this that you have to learn things the hard way. Okay? Hand tools on the job. Here's a statement and a half. Hand tools can be just as dangerous as power tools. Never underestimate the dangerosity. I just invented a word now, so I'm inventor. Uh, Never underestimate the the severity of the injury that can be done by hand tools or power tools. They are just as dangerous. So again, hand tools can be just as dangerous as power tools and other equipment when not properly, and we already talked about used, when not properly used. And then here's the thing, stored or maintained. Well, if you don't use the tool properly, yes, you can get injured because you are not handling the tool as it should be, and then you're compromising your safety while doing that. But if you don't store the tool properly, or sometimes some of the tools require a little extra maintenance, like keeping a little bit, keeping some oil, sulfur, putting oil on some surfaces, maintaining their structure and operability, whatever that word would be. Um, then again, you're compromising your safety by altering the state of the tool, which means you're going to try to handle it differently. You're going to compensate the way you use it to compensate for the condition of that tool, and that's where injuries can happen. Right? Also, when do injuries can, what's the when you're more prone to be injured? It's not when you're well rested. Yes, you can still get injured while you're well rested, or aware of your surroundings and all conscious and all that. But sometimes you're going to work long hours, and it just happens. Then you are tired. You're less aware of those things. Your sense of safety gets kind of, not as sharp as it used to be, as you were in the morning all rested and ready to work. And that's when injuries can happen. So that's when you develop proper habits, then you will do the proper things when you are tired and less aware of things, and your senses could be a little bit dull. All right, so your hand tools are an important part of your job and should be treated, cared for, and used in a professional manner. I would just say proper manner. Okay, professional is a big word. All right, these are the real pictures of some injuries on the site. Now, did I encounter some of the injuries? Well, working being on the job for more than 30 years, more like 35 or 6 years, yes, once in a while you come to a situation that you do something wrong, or something just basically happens. Yeah, I have nothing major, but let me tell you, just a little pinky, if you get your pinky hurt, it hurts, and sometimes it compromises the way you do things. So try to not get injured. Here is what you're paying the big money for coming to school here, me telling you, don't get injured. Well, I'm telling you how to not get injured, so that's the difference. All right. Da, 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 da. All right. It is estimated that about 8%, wherever that came from, but it's a significant number. It is estimated about 8% of industrial accidents involve the unsafe use of hand tools, both manual and power. These accidents result from using the wrong tool for the job. We talked about that. Or using the right tool incorrectly. We also talked about that. Or failing to wear personal protective equipment, PPE, or failing to follow the approved safety guidelines. Where do the safety guidelines come from? Unfortunately, most of the safety guidelines come from experience. So that means sometime in the past, could be a year ago, could be 50 years ago, could be 1,000 years ago. Somebody got injured in a certain way, and somebody else sat down to a table with somebody else and they discussed that, how can we prevent that from happening? Well, the hard hats, from what I know, the invention of the hard hats was not by the industry. It was not the government that told people to wear hard hats. It was the situation that made people try to invent things so they don't get injured while they're working. And so from what I know, I think I was watching some documentary movie some time ago. In the States, there's that Hoover Dam, or some originally was called the Bower Dam. So the workers that were working on constructing that dam, they would have some falling objects from up high, and so they decided to do something about it to address that, so they don't get hurt all the time. They don't get hit in the head. So that's when they sort of invented the usage of the hard hats. Now it's a normal procedure. Anywhere you go in the industry, you're required to wear a hard hat. Okay. Now, when it comes failing to approve to wear, okay. So here's the picture. What's happening here? Here's the proper tool for the job, but here's an example of not using it correctly. It's the correct tool, it's the correct job, but the tool is not used correctly. Always be aware of, look past that. You're putting a pressure with the knife. What's behind that knife? What happens if something lets go all of a sudden? Where is the knife going to go? Well, it's going to go into your finger when you hold it this way. Also, there are other things to think about. Like, for example, when you are using a knife or a sharp object, and you're required to apply some pressure and going towards you. What happens if something goes wrong? What happens if something breaks? If something lets go all of a sudden, then you're still applying that pressure towards you, and you're holding a knife or sharp objects. Well, you're going to drive that thing right into yourself. So that's one of those. That's one of those things that we should think about. What can happen if something goes wrong? And there's the last picture that I'm going to show you, and I actually magnified it and put it. I inherited this presentation, so I don't know why this picture is here, but this is an example of using the right tool, but not exactly the ideal situation. And every time I look at this picture, there's one thought that comes to my mind, and it's not the one you're thinking, I guess. All right. My thought is, I hope that this was just for the demonstration purposes, for safety video or safety awareness or something like that. And they were just posing to show some improper situation. Because if this is a real thing, then I don't know where we're heading as humans. All right. Okay, so that's where we're going to stop. We got 5 minutes to go before the class ends, and we're going to continue next time we see each other, which is going to be on Friday. Okay. I think we've covered everything that we should cover. Yes, we did. And some housekeeping. And if you're not sure about something, by all means, contact me. Email is the best, or see me during the lab time in order to clarify anything that you need to I need clarification on. All right, that's it for today, and have a great rest of the week. It's Monday, and as I say, it's almost Friday. You know why? Because every day is almost Friday. And with that happy thought, I'm going to say, see you when I see you. All right, thank you for your attention. Bye, guys. We will be viewing this part on Friday. Yes, we're going to come back to this. Plus, there's going to be another one. Okay. Cool. All right, guys. As you were. Thank you very much. Have a good one.